Perfect. Thank you very much for being here. Thank you very much, Lukas and Arne, for having me. It's very nice to come again. And actually, it was last year in January when I was here the first time. Lukas invited me to talk about the research I'm doing at the University of Bamberg. So actually, it's amazing to meet those people that I'm investigating. Yeah. So one of my research topics is to investigate the profession of data scientists and how this profession or occupation evolves, and also how managers can manage actively the data scientists, and also how companies can gain value out of their machine learning investments and data analytics investments. That's just part of my research. Together with doctoral students, I'm also working on concrete machine learning projects where we support, for example, the energy domains, for example, energy grid distribution or energy retail. And also we did a study where we helped students with machine learning and counterfactual explanations to become better in their studies. So we really try to implement machine learning and do this in a very concrete and very practical way. So that is on the one side I'm doing, and the other side is this type of study where I'm also talking to the people and try to do some qualitative research, which I'm not trained in. So I became used to doing qualitative research, and this is one of the outcomes of this work. Yeah, you all are involved in data-driven applications, I assume. Otherwise, you wouldn't probably not be here today. And yeah, we have those applications not just on the slides. Yeah, there is this famous Twitter post saying, AI is written on PowerPoint and machine learning is written in Python. Yeah, and a lot of AI applications are actually now written in Python. That's good because we see this really working. Yeah, so we have business analytics, this old stuff. We have now chatbots, robots. We have some autonomous driving, probably not on the roads, but in industry, in fabric halls or so, there are robots that are driving the goods from A to B. Then we have connected supply chains, and we are seeing much more applications that are actually working. However, behind those applications, there are the data scientists. And all these applications, they are kind of driven by their makers. And the question arises, what are those? Who are those makers? Who are these people that drive those applications? And there is a famous article by Davenport and Patil from 2012, actually. And that was the article in Harvard Business Review where they called data scientists the sexiest job of the 21st century. So this was a headline that was so much burned in our minds, the sexiest job. Everyone wants to be the sexiest job. And he described, 2012, this was really restricted to the Bay Area, right? So there were just those unicorns that are trained in physics and working with data. Companies didn't have that much data by that time. And they describe a data scientist as a high-ranking professional with the training and curiosity to make discoveries in the world of big data. But this still holds, I think. And when we look to the numbers, according to the US Bureau of Labor Statistics, the number of job postings increased from 2013 to 2019 by 265%. So that's a high increase. And according to the US Bureau of Labor Statistics, data science is the third most growing occupation in the next 10 years. There are just two occupations growing faster than it. That's wind turbine engineers and nursing. And then the data scientists come. So it's really a growing discipline. But on the other hand, we have, the numbers, it's very hard to find more recent numbers, but in 2017, the European Union forecasted that in 2020, we have almost 800,000 open positions. I think it's even more because when you look to Bitkom, the Bitkom members, 96% of the Bitkom members say they can't fill the data science positions. So it's really a high demanded job. And the question is, how can we mitigate this skill shortage when we don't know about this occupation. And that was my motivation to go into this topic and study data scientists. Now I have a little thought experiment to you. Just think about a team, that an ideal team that develops AI applications. What do you think? What comes to your mind? Sorry? So the LLM agent, okay, yeah. Domain experts are there, okay. Data engineers. Full stack engineers. So you are very much thinking in the roles. Yeah. Yeah, you need to bring the things into operation, machine learning operations, MLOps. What also needs to be there? Business, yeah, so a little bit the domain experts. So probably you think about this. Actually, so I gave a similar talk 2 weeks ago at the AI Navigator conference in Nuremberg, and that was the only presentation without AI-generated images. So yeah, we have perfectly trained specialists. We have structured work. We have standardized software components, high-quality data, smooth combination of internal and external resources, a perfect management of the AI projects, continuous and further development of maintenance of these applications. This is just things, a lot of that you already mentioned. What we think when we think about perfect AI teams. But yeah, that's not the case. Actually, in practice. I just collected some headlines. Yeah, data science projects fail. Nobody wants to share the data. A chatbot that suggests illegal activities. Yeah, so there are so many examples that we find from the news and from the media that AI projects fail. And the question is, what are the challenges in practice, and how can we overcome that? That was the motivation. That was the main question where we started 2018, actually, with colleagues from Copenhagen and from Paderborn University. We started to contact our network of data scientists and started talking to them. And a study emerged out of that. So in total, we talked with 40 data scientists working in 55 data science initiatives. We have large firms, medium and small firms around the globe in different industries. We had, in the end, over 600 pages of interview transcripts, and then we started to analyze that. And so what we did is, I called it a maximum variation sampling. So we really wanted to have a broad overview to everything. And then, in the end, our results, we looked at the results, and then we considered, oh, actually, we found problems that we already know. So we formulated challenges to data science work. So one challenge is inflated management expectations. I will talk later about those in detail. Then we found that a lot of people are managing AI projects like traditional IT projects. We found that there are missing data input and data output links to the existing systems. The question of why, and dynamic environments. And then when you start with qualitative research and you interview people and you document what you found, then you usually find out something that is very obvious. Because people tell you the reality and you document that, and everybody is saying, we know all this. And that was also the point. We submitted this article to a journal and they said, we know all this, why should we publish that? And that was the point, and that is the point where qualitative research starts, looking at the data and scratching the head. Looking at the data and scratching the head. And yeah, after 2 or 3 years then, we got this paper out, and now just recently we got 2 best paper awards for that. It's open access, so you can just read it. It's published in California Management Review. I also have the QR code in the end, so you don't have stress to scan it now. You can also scan it later. And yeah, so basically that was our starting point of our thoughts, and we looked at those challenges and we found that when you look to data scientists and to the other stakeholders the data scientists are interacting with, there is a tension. And this comes from the different approaches of making. So this is really the basics of doing business. When we started with the industrialization, so before the industrialization, everything was manual work. And then there was the industrialization and the idea to distribute labor, and also the idea of creative destruction. So when there is a more efficient way to do it, then you will do it. And this led to organizations that have bureaucratic structures. So you have management levels, you make it more efficient. And the most extreme is this gig economy, like Uber. So the Uber driver is not deciding anything. The app is deciding where the Uber driver drives, and how is the waiting time, and where the driver drives next, and so there is no decision by the Uber driver anymore. It's just the app who is deciding. So it's basically broken. The work is broken down in very, very distinct tasks, and that is kind of the gig economy. And that's the most extreme what we could think of, breaking down the work and making it more efficient. And on the other hand, we have craft. In German, Handwerksarbeit. Yeah. So the craftsman who is in the early days making shoes, making clothes, building houses. So this is craft work. And actually, there is a resurgence of craft when we think. So we have, on the one hand, we have this automatization and this professionalization of the work, and everything will be automated. So people really tend to be individualistic. So we want to drink craft beer because we have something unique. We want to have handcrafted handbags or handcrafted pottery. And when we go to holiday, then we want to buy a very specific takeaway that we bring, and it's unique, and we put it onto in our room, and we think we are very unique. And so there is this tendency among the people, but there's also the tendency in research. So in the last years, there was a resurgence of craft in management studies, and there was a paper by Krösen, 2021, where they did a literature review and found that craft is growing, actually. And that's kind of the opposite of this automatization movement. And they have put up a very nice framework talking about craft in comparison with this other approaches of work. And I want to briefly explain this framework to you, because that helps us later to understand the tensions in craft in data science work. So Krösen said that craft is defined by a set of skills and attitudes. So how people approach the work and what skills they bring with. While in the automated mechanical work part, you have a lot of commodity. So everything, you can put it out of the shelf. There are books where you can read everything. Yeah, so you can obtain the knowledge, this abstract expertise. So you can go to a school and you will be taught everything that you need to work at Mercedes, Volkswagen, or BMW on the industry floor. Yeah, and it also doesn't depend. That is here below. It doesn't matter if you are working for Mercedes, BMW, or BMW, or Volkswagen, because you have the similar skill set. Everything is very specialized. So people are also very individualistic. So we have on the mechanical work part, we have labor unions. And the labor unions, actually, they fight for better tariffs. They fight for very individualistic approach goals, right? So increasing the wages, increasing the labor conditions. While on the other hand, when we think about craftsmen, they also have associations. These, how is it called in English? These Innungen, these associations of craftsmen. And they don't fight for higher wages or working conditions. They try to optimize markets. They try to improve the education and training of new people. Yeah, so they have a different goal. So on the craftwork perspective, we are very much focused on the mastery instead of the commodity. So it's really the product and the hand, how I produce this product. And the craft workers, they also have a very high aroundness. Yeah? So they have a variety of tools, and they experiment with those tools. And they have a very high embodied expertise, it is called, which means that it's very hard to tell people about what they know. So there is a lot of tacit knowledge, which is very hard to formulate. And they have a lot of dedication. So when you think of a brewer of craft beer, the person is very attached to that, and they design their own labels. They don't have a marketing agency. They are their own marketing agency, right? And also when there is a person doing pottery, then they are dedicated to, and they really love it, and they define when they are finished, not some timekeeping or something else. They have this commonality aspect, and there is much exploration in that. When you think about this framework and your own work, probably you will find evidence for both sides. And we will see that later on as well. Now I go to those challenges that we identified, and so that is just what we found from the interviews we did. We have the first challenge is inflated management expectations. And on the one hand, we have a manager who says, we need to have AI in the process, please implement it. Yeah? There is this advertisement in the radio from Sparkasse, where they ask, when should I update my company to AI? And I thought, what? That's not possible. But that's the managerial perspective. Yeah, can you install the update and then we are AI? Yeah, that's the expectation. And the data scientists, they have a high dedication, and it's very hard to build those systems. And there's also a lot of expertise involved, right? A lot of data scientists can tell what is the perfect parameter set for an algorithm. They say, yesterday this worked out and the result is good. Why should it change it? Yeah, so there is this high mastery, and this hard to explain why they did it sometimes. I'm always talking in very extreme situations today, probably. They also need to communicate to a variety of stakeholders, while in normal IT projects, it's very clear to whom to communicate and the role distribution and something like that. What we did in the paper, I probably don't read it out here, everything. We identified tactics how to overcome those challenges. And we also explained it in the paper. Here, for example, to resolve this management expectation clash, you can establish tools for a quick reality check. So when businesses coming and say, we want to have AI in the process, then you have a very simple checklist where you can just check, is it possible to do it? Or start small, iterate, and grow. Yeah, so this incremental development is something where you can approach these issues. The second is that people are managing AI projects like traditional IT projects. And the management perspective is often that, it's just like this Sparkasse advertisement. Yeah, it's just like an update when you implement AI, but it's actually different. Yeah, so they don't understand the complexity, and it's very exploratory partly. So the data science perspective is rather that you see AI applications as learning agents. So rather see it as a new employee that you need to train the new employee, and also create the environment that it works perfect. What I found surprising, and that is something that I'm still exploring, that a lot of people said that these agile approaches like Scrum also don't work for data science projects. Even if you say data science projects need to be very agile, but the agile approaches need to be developed that they fit to the agile development. This is something I find very interesting, and you find controversies when you talk to different people. I had someone also saying, so we are developing all AI projects with Scrum. I don't know if this works for all companies. Yeah? So there are limits.
Sorry?
Yeah. Sure. Sure.
I was immediately triggered when you called Scrum an agile process. I think that's highly debatable. Scrum was invented to reduce project lead times for going into production from a couple of years to 6 months. I would not consider that very
And thank you, because that shows us that it's very controversial. And actually, what we also figured out that it's really dependent on if you're talking about very experimental projects or if it's really more standardized and you know what to do. Yeah, and many AI machine learning projects are very experimental and therefore it doesn't fit. Yeah, just one explanation. What are tactics? So data scientists can train managers on the job. So it's really advisable that managers sit next to the data scientists and just experience one day how they work. Yeah? To learn the expectations a little bit better. Then also basic AI and machine learning courses for managers. And actually the management education reacted to this, probably not our paper, but in general, when you look to the business schools, St. Gallen, Copenhagen Business School, Vienna Business School, they started to include programming in the basic education. And that's, I think, a very, very important step because we have digital X, yeah, digital is everywhere, and therefore we also need to train managers to do programming. I mean, I'm not saying that programming means that they understand what machine learning is, but it's actually one step in the right direction. And also appropriate KPIs. So you cannot measure the success of machine learning projects with the same KPIs that you measure a software project. Yeah, then a headache topic for many data scientists is the missing data in and output links to existing systems. So I had one data scientist saying, it's perfect, I get the data out of the system, but I never get it in. I never get the data back to the system. And so we have it in both ways. Sometimes the system frequently changes and always you need to readapt the pipeline. And on the other hand, it's very difficult to get data and predictions back to the legacy systems. So yeah, I mean, management can say the interoperability of AI and IT is just a matter of interfaces, but probably it's not because it's very hard to define new interfaces for existing software. And the other thing is that AI, when you think about AI or machine learning applications, that usually the whole business process needs to change. Because you can do things that cannot be done before, so you need to rethink the whole business process, and that's not just installing an update. And for the data scientists, I called it maneuvering the fluid of data, because there are so many different data types and shapes of data, and you need to combine a lot of data, so that's really hard to define a standard process for doing this. So one approach is what really helps is increase data awareness, and often it's the case that you really start with the machine learning projects to increase the data quality. So you prioritize projects that you usually have started 20 years ago when the big data and business warehouse, data warehousing, data integration project started. People now understand why they need it, yeah, because otherwise you cannot do machine learning. Another pain point is the question of why, and I mean, in the meantime, I mean, we conducted this, we started 2018 with the interviews. Today we have much better frameworks for having explainable artificial intelligence and explainable machine learning. However, it's when you think about machine learning and doing predictions, that's not what managers want. Managers want prescriptions. So managers want to get to know what they should do and not what they could do. Yeah, and this means, on the other hand, the data scientists need to be very well trained what the decision options are, and that's really hard to formulate. Yeah? So these are two worlds. The data scientists and data analysts, they think in predictions, but the managers actually need prescriptions. That's one thing, and the other thing is then also when it comes to high-stake decisions, so when there are decisions made where a lot of risk is involved, then managers usually want to understand why this prediction was made. And yeah, I mean, today we have much better post-hoc explainability methods. Then one recommendation is that you don't use Gen AI for everything. Usually I always say you can use Gen AI for some tasks, but when you want to have a very simple forecast, then usually simple statistical approaches are very well performing when you do a little bit more data preparation. Yeah, so thinking the problem through and start with simple methods is a very good good help, because they can be explained and even managers understand it, because they have hopefully they had a good statistical introduction. Yeah, and then what I think is very important is this causal modeling, causal machine learning, where you really make experiments and learn out of that. I think this is something where we have also technological developments to overcome this problem. Yeah, in the end, I mean, I think you are much more involved in that. We all know about data drift and problems that models become worse over time. And this is also something that managers don't have on their radar. That when you put something into production, it's not even continue working for 10 years. Yeah, you need to update the models, and that is something that a lot of people don't expect. So you need to monitor this, and also this ML ops is something that one of you said in the beginning. Machine learning operations, we need new KPIs for this and also new approaches. Yeah, so on this point, we have this tension between the craft work and the management, the mechanical work perspective, and this can explain a lot of these tensions in the data science projects. When we consider this and make those stakeholder shift in our view on the problems that are there, that helps a lot, I think, to resolve those conflicts. So this is something, an advice probably that I can give you with projects that are kind of seem to fail, then probably it's something where you can use those tactics. At the moment, we are continuing this craft idea in our research, and we thought when craft workers work with products, they also have material and they have tools. So these are the three elements of craft work. And so we identified in another interview study, we identified practices how the data scientists work with the material, the data, with the tools and with products. And usually it's the case that the craft workers, they sometimes craft their own tools, yeah? And they craft the products, but in data science it's much more, they also need to craft the data. And this implies that when you recraft the data, then you need to recraft the products. So in data science, there is no, you don't have a fixed product in the end. The product is always changing, and this is something that we need to reconsider, because a traditional craft worker sold his product or her product on the market and then it was done. But in data science, you need to always resell the product because it changes over time. And this is a challenge that I think needs new approaches, and we are, I think, at the beginning of this journey to better understand how this works. Yeah, then we also have other actors, IT staff, managers, employees, and community. This is also different to the IT work, because IT work has IT and management or business departments, but data scientists has business departments, IT, BI department, and the data science world. So it's much more complex, and we need to find ways to communicate between those boundaries. Implications, both perspectives are relevant. While the mechanical work, the business perspective, increases efficiency, the craft work perspective increases effectiveness. Yeah, so effectiveness means the solution works, and efficiency means we come to an end, yeah, with development. So we cannot do one of the sides. It's like work-life balance. That's another paradoxical tension. Work-life balance, when you over-prioritize private stuff, then your work will not be done, and when you over-prioritize work stuff, then your private life will be destroyed at some point. So you need to manage this paradoxical tension. You cannot meet just one, and that's the same here. So you need this efficiency and effectiveness. You need to make both ends meet. The paradoxical tension, so there's a paradox theory that connects to this, and in the paradox theory we say that the elements of the paradox are always active. So you cannot just satisfy one end, and you cannot resolve that paradox. Yeah, so you need to always actively, continuously, argue between and find ways how to fulfill both requirements, and the tactics that we presented in this article probably help for the field of data science to as practical tools. Yeah, I think I will stop now talking and invite all of you to discuss, ask questions, or contradict. I'm very open and happy to open the discussion now. Thank you very much. Yeah.
Exactly your definition of a data scientist. Because it's, I think it's not so clear. What you mix sometimes concepts. I don't know. So I'm really interested though.
Yeah, so that's a difficult question, because everybody is defining a data scientist differently. When you look to 3 organizations, then they will define the roles differently. So some companies have data engineers that do more technical stuff. Some say that data science are more business oriented. I use it as an umbrella term, actually. So I am defining all the machine learning data work people as data scientists, knowing that this is a very broad definition.
Yeah, I want to crowdsource this question. So who here defines themselves as a data engineer? So data science, data scientist. So we have some data scientists. Click it on, please. Oh, sorry. So the question is, who here in the room defines themselves as a data scientist? And then we can ask them how they see it. Like, maybe here.
Yes, Konstantin mentioned it's an umbrella. So sometimes data engineering, sometimes business is a mixture. So there's no clear definition on this, I think. But there's a feeling you have a gut. Okay, what is a data scientist doing? And that's usually from company to company very different.
But there's some full-time scientists here, data scientists, so who only do the...
I am, but I do Python, I do business, I do data analysis, I copy data from A to B. Yeah, so.
But then you're data engineer-ish too.
Ish, yes.
Yeah, that's what I mean. Is there somebody here who's only doing the...
Okay, what do you mean? Creating a model and then testing it the whole day?
But I mean, that's exactly the point. I think that that the data scientist stands between the chairs and are not separated. So it's really like a proxy between management and. So if you do it, I mean.
It's a team and not a person.
Yes.
And so the question that I'm always struggling with is: so is this a temporary phenomenon? So when you think about 10 years' time, so do we have those clear defined roles? Do we industrialize data science and AI engineering? So the vision would be that we have at some point AI engineering, like we had software engineering. In the 1950s, 1970s, they had a lot of failed projects with IT, and now we have models and roles that it works. So do we have it in 10 years or 20 years' time and have those clear defined roles? That's one question. So is this all temporary? Will we be having resolved it in 3 years? Arne. Okay, here.
No, I call myself a data scientist, and I would try to put it into words. So model building, I think, is one of the main things as well. And as people normally put it, it's a unicorn, or he or she is a unicorn. So it comprises of a lot of different things. So I'm doing authentication, deployments, and one might argue, hey, is this really data science? I think it also has like a research angle to it. So I think of it like a T. So you have a vertical part where you specialize into research and algorithms and structures and so on. And on the other side, like it's much broader in that sense. And if you look so all the statistics were great. But I think it's also evolved in the last couple of years where people said, hey, he or she is looking for a unicorn, to the recent times in 2024 where they say data scientist as a profession is dead. So you have such contrast here that you don't really know how people perceive it, and it's a much broader topic. Yeah.
Yeah, on that question, what is a data scientist and how will it develop in the future? I think there will be another term just because it's, well, yeah, it used to be the most sexiest job proclaimed in 2012, but then becomes a trend, and I think this trend will just eventually fade. And there will just be a new term for exactly the same thing. The problem is that data science already is something that is very fuzzy. It's overlapping with other things. Like, you cannot be a good data scientist if you're not a data engineer as well. It's simply not possible. Now, most data scientists, or a lot of data scientists at least that I worked with, they had nothing to do with data science. They were doing data analysis. They were data analysts, right? So they took raw data and took the same data, they didn't really change it, maybe cleaned it a little bit and put it into very nice dashboards for the business side to work with. And they were just nice-looking dashboards, that's all. For me, the textbook definition of the data scientist is extracting insights from data, ideally from large amounts of data. Extracting insights that business-relevant decisions can be made up on. Like if that's not given, then this is not a new role. This is not different from roles that already existed in the 90s. And I think that's the key. Well, yeah, the keys that you have to have. You need to have big data, you need to have new information, new insights extracted out of the data, and it needs to help business decisions. If it's not in a business context, you just have a hobby of looking at data and doing something with it. And then, of course, this machine learning aspect came into it over time. And became very, very important because it turns out that machine learning and data scientists are basically siblings because machine learning turned out to be the best tool to do a lot of data science.
Yeah, thank you.
Any other comments or questions?
So is the question answered?
What I hear is data science at its definition is like not management, so it's more like a universal job. So really getting insights and stuff, and not, in my opinion, not necessarily big data. It's just you have now a new tool set and you apply it, and you need to communicate with management, communicate with domain knowledge, communicate with data things, and stand in between, and also like doing this engineering and pipeline stuff and whatever. So it's really not. So, but I mean, yeah. Sometimes it's so on your slide it was so separated, and so that was more my point, that it's not that separated. So this analytics stuff, and so it's more on the right side, but data science is more in between. But it's maybe just.
Yeah, actually, yeah, that was the struggle. The struggle we had. So we found evidence for both perspectives, which is contradicting the theory actually, that you have those divide.
If I may ask a question now, I have the microphone, so I can do it.
Go ahead.
In my experience, depending on the company, even on the team, or even the background and the skills of people, you have very different kind of clusters of data scientists. You have like these people, the generalists, maybe the T-shaped experts, as we heard. But then you have really sometimes you have really people they can only do, they maybe can't even do very good programming, but they are very good statisticians. And then you have more the data engineer types, but all get called data scientists. So maybe it would be interesting to even have some research where what kinds of clusters you kind of can have as a data scientist.
Yeah, that I would find very, very interesting, but it's really hard to get this because not much research is done in this direction. I think an important moderator is also the company size. So you have the data scientists a single data scientist sitting in a company and doing everything like you described. And then there are those large data science teams where you have 20 data scientists and you can really distribute the roles. Then you have more business-oriented people, then you have more data-oriented people, then you have the machine learning who just can do large language models. and neural networks, and don't do anything else. Yeah, so this really depends on the size of the company as well.
Okay, we have another question here.
Yeah. Well, it's an idea, whatever. I noticed you were talking about agile methodologies and Scrum, and I see Scrum a bit as being agile, but one-way agile. Like you are agile to changes in requirements from the coming from the business side. But I sometimes feel it would be great to be two-way agile, especially when data science, when you have something that is more craft related and so on, that you also get the business side to adapt to changes in the that you find out from the technical side, that you see, oh, we can do something, solve a more general problem in an easy way. Does this help? Can we redefine the workflow or whatever, something, make everything easier, better, whatever now with this tool, but this flow in the other way around, I don't see that happen a lot in practice, and I would like to get some input and or feedback on this idea.
Yeah, thank you very much. I like this idea of being one-way agile in the direction of that the customer can change the requirements and the people who implement it realize it, but not the other way around. That's a very nice way of thinking, because in data science or in database applications or machine learning applications, you need exactly that, because that is something that with Scrum or other agile methods, you can adapt to user requirements, but you cannot adapt to data changes. Yeah, so that is not part of the planning in those approaches, and that can be one source of communicating in the other way around. So I like this idea. I think we need to have a broader sense of being agile in terms of growing. So start small, growing, iterating, and being. So that's the non-German way of thinking. So failing. Yeah, failing and learning out of the failure. That's something that we are not very good at. I think the overseas people in the US, they are very good at that, and it's okay to fail and learn out of the failures. And I think we need to do this in a more agile way, basically, probably with less legal frameworks. But on the other hand, so what we have done, that was the other side of the study, which I presented 1.5 years ago. What we did is so from those interviews we thought we want to identify what kind of applications are developed there, and we found that we have this classical automation versus augmentation. So there are applications where people are replaced, and there are applications where people are improved. Basically, and then there's also this knowledge creation where you just create a dashboard and have insights out. And the main finding there was that the projects shift in between. So there are projects that start with knowledge creation and they become automated systems, but also the other way around. So you start with a very ambitious project and you fail, and then in the end you have learned a lot. And so out of this, we also defined a process model where you can switch between those types of value creation in the company, and that's also a way of agile thinking. Yeah, don't talk about failed projects. Think of what can you do else out of the project. And yeah, that is something I think is part of those agile I don't want to call it mindset, but these agile approaches, not just focus on one Scrum or Kanban as single methods.
Any other comments or questions? I will try to get to you here.
Thank you for the presentation. I was wondering, you showed us a list of factors that cause problems in data science projects, and you talked with data scientists about it, right? The list you showed us, the factors.
This in the beginning was the.
No, you had 5 factors, I think, right?
Are these challenges?
there are challenges, right? Challenges, sorry, challenges. Like, could you, when you were talking with data scientists, could you find challenges that were like one or two that were the major challenges that caused more problems than others? Because like, when you heard some presentations, you already got to know some of them. And if you talk to a lot of people, it would be very interesting to hear maybe your opinion on what is the most evil of all of them.
Yeah, so probably it's, I think the inflated management expectation is one of the most important challenges because you have this communication gap between different worlds of work, right? And this is a little bit connected to the management of IT projects and AI projects because managers manage, and when they don't understand it, they cannot manage it very well. So I think this is one of the most important things, and then it really depends on the context. Yeah, this question of why is something that has just to do with high-stake decisions, where you really need to know why is that recommended and not something else. And the missing in and output is probably more in systems where you really want to automate processes, where you really want to feed back things into. When you just have insight generation, then you don't need to feed data back to the system. Yeah. But in general, what we think is that this craft versus mechanical work is something like a meta challenge. It's like a meta explanation to all of these. So we find in all of those five challenges, we find this divide, what I showed in the separate slides. And I think when we adopt this perspectives and think of the different viewpoints on the same problem, then I think we can not resolve it, but better manage it.
Thank you.
Yeah, welcome.
Maybe one final question, and before we go to our lightning talks, somebody here. Yeah.
Not a question, but a remark. I think that the tensions that you actually showed us are not specific to data science, but more on the broader side to everyone who is working in IT in a more explorative and more craft-oriented way. So, for instance, I myself identify more like a software crafter, and I experience many of those challenges almost every day, especially with traditional management departments.
Yeah, actually, there's also research describing software craftsmanship. So there are some studies that identify craft in software engineering. So we are all crafters, basically. Thank you so much for listening and having me, Lukas.
Yeah, thanks, Konstantin.